Hi, this is Math 6, Lesson 3-2, the second lesson of Topic 3. In this lesson, you'll write the prime factorization and find the greatest common factor and the least common multiple of two numbers. So you'll find the prime factorization of a whole number, and you'll find the GCF, greatest common factor, and the LCM, least common multiple of two whole numbers. You'll use GCF and the distributive property to add. You'll use the GCF and LCM to solve problems. And also language-wise, you'll also be able to explain how to write the prime factorization and find the greatest common factor and the least common multiple of two numbers. Let's look at solve and discuss it. Mark sets the dinner table every 2 days and dries the dishes every 3 days. If he sets the table on day 2 and dries the dishes on day 3, on what day would Mark first perform both chores on the same day? Okay, so he has a pattern. Think about the pattern. What chores do you do at home? Do you have a chore schedule in your household? Do you help your mom wash the dishes or maybe do laundry? Okay, over here, Mark helps set the table every 2 days. So every 2 days, he's gonna set the table. Today, if he set the table, tomorrow he will not, but then the next day he will. Okay, so every 2 days. And washing the dishes, drying the dishes every 3 days. So if he dries the dishes today, he will not dry the dishes for the next 2 days, but he will do the 3rd day after today. Okay, does that make sense? So let's think about his pattern. If he sets the table on day 2, so you can say day 2, he sets table and dries the dishes. Okay, what day would Mark first perform both chores on the same day, right? So sets table, he does it every other day. So let's write T for table. Okay, 4th day, he will set the table. Dishes, he will not dry the dishes until the next 3rd day, right? So the 6th day, he will do the dishes. Let's change the color so that you can see better. On the 6th day, he will do the dishes. Will he do the table on the 5th day? No, but the 6th day, yes. So is this the first day he would perform both chores on the same day? After day 2, yes. On day 6, he will do both, setting the table and doing the dish, drying the dishes. Okay. So day 5, he will not do anything. So let's complete our table down here in a more organized way. Day 1, no information, but we're gonna say no, okay? Day 2, he sets table. Day 3, he does the dishes. Day 4, he will set the table. Day 5, he will do nothing, okay? Day 6, he will set the table, and 1, 2, 3, he will also do the dishes, okay? 7, none. 8, he will set the table. Okay, so table is every other day. Let's use different colors to see it better. T, 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 every other day. Dishes every 3 days. Dishes, dishes. 1, 2, 3, dishes on the 9th day, on day 9, right? So then, on what day will Mark do both chores on the same day again? So 6 was our first answer, right? Day 6, he will perform both chores on day 6. Okay. And then keep going until you hit another day. Okay. Day 9, he will do the dishes. Day 10, nothing. Day 11, wait. Day 10, he still needs to do tea, right? Setting the table. And then day 11, none. 11 is none. And then 12, table again, 1, 2, 3. 1, 2, 3. So doing the dishes again. So day 12 will be the next day. He will do both chores on the same day again, right? So you can say on day 12. So do you see a pattern? We have day 6 and day 12 where he does the dishes and the table at the same day, on the same day. So we can say Mark will do both chores every how many days? 6th day, right? So every 6th day, he will do both. Day 6, day 12, and then after you figure out the pattern, you can see that day 18th, he'll do both chores. And then 24, and then 30th, 36, and so on, the multiples of 6. Okay. Let's look at the next page. Think about this question throughout this lesson. How can you write the prime factorization and find the greatest common factor and least common multiple of 2 numbers? Okay. What's the greatest common factor? What's the least common multiple? Let's look at some vocabulary words. What is a prime factorization? First of all, whole numbers greater than 1 are either prime or composite numbers. Okay, prime and composite numbers are opposite vocabularies. They're the antonyms, okay, in math. The composite number can be written as a product of its prime factors, called its prime factorization. If it's not a composite number, it's a prime number. If it's not a prime number, it's a composite number, okay? 1 prime, 2 prime, 3 prime, 5 prime. 4 is a composite number because it can have other factors other than 1 and 4, which is 2. 2 times 2 is 4, right? So it's a composite number. How can you find the prime factorization of 48? So 48, all composite numbers can be written as multiple of prime factors. You can keep dividing it until you only have prime numbers left for your factors, okay? 48, think about 48. You can think about the factors that can divide 48 into 2, right? First, think about prime numbers. First, you can come up with 2. It's an even number, so you can divide by 2 and you get 24. That's also divisible by 2. So rewrite it as 2 times 2 times 12. That's 48, right? And then you break down 12 again. That could be written as 2 times 6. 2 times 2 times 2 times 6. Can you break down 3 into a smaller number? You have 2 and 3. 2 times 3 could be 6, right? So you have 2 times 2 times 2 times 2 times 3. Can we break down any other numbers by any other factors? No, they're all prime numbers. 2 and 3 are prime numbers. They only have factors of 1 and itself. So the prime factorization of 48 is 2 times 2 times 2 times 2 times 3. And you can write that as a power. 2 to the power of 4 times 3. I think that's a typo. It should be 3. Okay. You can also use something called a factor tree to figure out the prime factorization. You can start with 48 and then factor out a prime number times a composite number. Okay, 2 times 24. And then you can factor out 24 again to a prime number and a composite number. And you can keep doing that until you only have prime numbers and you cannot go further down. Okay, so you can look at the ends of the factor tree. You have 2 times 2 times 2 times 2, 4 2's. So 2 to the 4th power times 3. Okay, that is called a prime factorization. Let's figure out the prime factorization of 56. Start with the least prime factor, the smallest prime that you can think of. You have 2 because 56 is an even number. It's divisible by 2. 2 times what would be 56? 28. Can you divide 28 into 2 again? Yes. 2 times 14 is 28. And 14, divide 14 by 2. 2 times 7. Is 7 a prime number? Yes, 7 is a prime number, so you can stop there. How many 2's are you multiplying? 1, 2, 3, and 1, 7. So write this in a power. 2 to the 3rd power times 7. If you have different numbers, you cannot combine them in the powers. You have to separate them because they're different. They're just different bases, right? A number is greater than 2 and it has a factor. 2 as a factor. Is the number prime or composite? Explain. Number is greater than 2, so it's not 2, and it has 2 as a factor. By definition, what's a composite number and a prime number? Prime number cannot have other factors other than 1 and itself. So it only has 2 factors, itself and 1. But if you include 2, so for example, 4 is greater than 2 and it has 2 as a factor. Is that a prime or composite? It's a composite number. Okay, how would you explain this? All even numbers greater than 2 are composite numbers. Okay, only 2 is an even number that is a prime number. Okay, look at example 2. Find the greatest common factor of 2 numbers. Keisha is putting together bags of supplies. She puts an equal number of craft sticks and an equal number of glue bottles in each bag. There are no supplies left over. What is the greatest number of bags of supplies that Keisha can make? Okay, we got 12 bottles of glue, 42 craft sticks, and there is no remaining supplies after this is done. So how can you pair them? First, we're going to identify something called the greatest common factor. What is the greatest common factor? GCF is a factor of 2 or more numbers. So we're going to look at all their factors. Let's factor out 12 and 42. Let's make a prime factorization. 12 could be written as 2 times 2 times 3. 42 could be 2 times 3 times 7. Do we have common factors? Yes, we got 2's and we got 3's. And can we multiply them to get 6? Is 6 divisible by, can 6 divide both numbers? Are 12 and 42 both divisible by 6? Yes, that's how you get a greatest common factor. 6 is going to be the biggest number that from their factors, all their factors. If you don't know how to do this, you have to list out all their factors. 12 will have 1, 2, 3, 4, 6, and 12 is all their factors. 42, 1, 2, 3, 4, 6, and then 8, and then 11. No, there's no 4. I'm sorry. And that's going to be 16. And then you got 21 and 42. Okay, there you go. These are all the factors of 12 and 42, right? You find the biggest number that they have in common. They have 1 doesn't count really, 2 and 3, and 6. So 6 is the greatest common factor for them. Nothing bigger than that would they have in common. So this is called the greatest common factor of 12 and 42. And this is how you get greatest common factor easily using the prime factorization. Getting all the common prime numbers and multiplying them together makes a greatest common factor for both. So the greatest common factor is 6. Why are we getting greatest common factor? Because she can make 6 bags of supplies with 12 bottles of glue and 42 craft sticks. Okay. So let's look at try question. Keisha has 24 beads to add equally to each bag. Can she still make 6 bags and have no supplies left over? So in other words, is 6 GCF, greatest common factor of 24, and Keisha has 24, 12, and 42, right? She's gonna add a supply. So is 6 the greatest common factor of 24? Okay, so let's write down the prime factorization for these 3 numbers. So 12 was 2 times 2 times 3. 42 was 2 times 3 times 7. We need to prime factorize 24. Let's use the factor tree. 2 divided by 2, you have 12. Divide 12 by 2, you get 6. Divide 6 by 2, 3. And that's our prime factorization of 24. Okay, 2 times 2 times 2 times 3. And how many common factors do we have? We got 2 for all 3 of them, and we got 3 for all 3 of them. Do we have anything else? So greatest common factor for 3 of these numbers is going to be 2 times 3, 6. It's still 6. Okay, so yes, 6 is still the GCF of all 3 numbers. Okay, that is why she can add 4 beads to each bag. She can add 4 beads to each bag. Okay, because 24 divided by 6 is 4. So if she adds 4 beads into each bag, you have 6 bags total, and you have no remaining beads. Example 3, use the greatest common factor and the distributive property to find the sum of 2 numbers. So after you find the GCF, you can use the distributive property to find the sum of 2 numbers. Okay? How do you do that? Of course, you can just add them, but this is another way to find the sum of 2 numbers if the numbers are too big. Okay? So write the GCF. Figure out the GCF. GCF for 18 and 24 is 6 again. And 18 plus 24 could be written as 6 times 3 is 18 plus 6 times 4 is 24. So you can go backwards into distributive property and say Oh, we have this greatest common factor that's multiplied. So I'm gonna multiply 6, parentheses, 3 plus 4. Because if we use the distributive property, what does this do? 6 times 3 plus 6 times 4, and that's where we started it, right? So we're thinking backwards into distributive property. And so 3 plus 4 is 7, so 6 times 7 is also 42. 18 plus 24 is 42. So if you get used to this process, it will help you solve for the sums of greater numbers, bigger numbers, faster. The sum of 18 and 24 is 42. Okay, so try using the GCF and the distributive property to find the sum of 12 and 36. For this one, you need to show all work. You have to use the GCF and distributive property. You cannot just add them, okay? So figure out the GCF. What is the GCF? 12 is 2 times 3. 36 is 2 times 3 times 3, right? So GCF is 2 times 3, which is 12. So 12 plus 36 could be written as 12 times 1 plus 12 times what makes 36? 3. So you have the same GCF 12. Use the distributive property backwards to get 12 times 1 plus 3. And that could be written as 12 times 4. You multiply 12 times 4, you get 48. 12 plus 36 is 48. Okay. Let's look at page 32, 132. Find the least common multiple of two numbers. So what's the least common multiple? Let's look at our example first. Grant is making picnic lunches. He wants to buy as many juice bottles as applesauce cups, but no more than he needs to have an equal number of each. So in other words, no remainder. How many packages of each should Grant buy? He got 6 juice bottles per pack, 8 applesauce cups per pack. Okay. He wants to buy as many juice bottles as applesauce cups, but no more than he needs to have an equal number of each. So we're going to find the least common multiple for these numbers. Least common multiple is the least multiple. You multiply the numbers, not factor out, okay? Not including 0, common to both numbers. So look at the prime factorization of 6 and 8. 6 would be 2 times 8. 8 would be 2 times 2 times 2. You're going to list the greatest number of times each factor appears in either prime factorization. What does that mean? You're going to look at how many times each numbers are multiplied by. So every different base, every different prime factor you see, you're going to multiply them out. Does that make sense? So here 2, how many 2s are multiplied in 6? Once. In 8, 3 times. So 3 times is greater than 1 time, right? So you're going to multiply 2 3 times. And you have 3 multiplied once. So you're going to include 3 2s and 1 3s. You're going to multiply all of them together. 3 times 2 times 2 times 2 is 24. And your number must be greater than 6 and 8 because we're thinking of the smallest number that both of them can multiply to get, right? 24 is the LCM of 6 and 8. So you want 24 bottles, juice bottles, and 24 applesauce cups. And that will get him to buy how many bags? He should buy 4 packages of juice and 3 packages of applesauce. Okay, if he buys 4 packages of juice, so 6 times 4, he gets 24. If he buys 3 packages of apple juice, 8 times 3, 24 apple juice, right? So he has the same number of juice and applesauce, even if he buys them separately, right? So let's try the last question. Grant also buys bottled water and juice pouches for the picnic. There are 12 bottles of water in each case and 10 juice pouches in each box. Grant wants to buy the least amount but still have as many bottles of water as juice pouches. The same problem. How many of each should he buy? So he needs 1, 2, 3, 4. So how many water bottles do you have in one pack? 12. 12 water bottles in one pack. Okay, and then 10 juice pouches. 10 juice pouches in one pack, in each box. Okay, so you're gonna figure out the LCM. Prime factor, use the prime factorization for 12 and 10. 12 was 2 times, okay, divide them until you cannot. So 12 is 2 times 2 times 3, right? What about 10? Divide 10. 2 times 5. So 10 would be 2 times 5. And so look at the different prime numbers. You have 2 multiplied twice. That would be the biggest number of multiplication, right? So 2, your LCM is 2 times 2. And then you have 3. So you got to include 3. And you have 5. So you got to include 1, 5. Okay, you need to include all the different prime numbers. But if you have the same prime number, you're going to choose the prime number with how many times you multiplied the most for each prime factorization. Does that make sense? You're not multiplying the total number of the prime numbers. You're choosing just one from each factorization. Okay, so 2 times 2 times 3 times 5 would be your LCM. Okay, which is 60. 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So in order to make 60, how many water bottles do you need? 12 times 5 is 60. 10 times how many is 60? 6 is 60. So how many packs of water bottles and how many boxes of juice pouch do you need? 5 packs of water bottles, 6 boxes of juice pouches, okay? 5 cases of water and 6 boxes of juice. Okay, explain that the LCM of 10 and 12 is 60. So 60 is the least number of both water bottles and juice pouches that Grant can buy to have equal amounts each. Okay. Whoops, I double T'd the water. Got confused with bottles. Juice pouches that Grant can buy to have equal amounts of each. Okay, so let's summarize our lesson. What did we learn today? The GCF and LCM, greatest common factor and LCM. How do you find the greatest common factor and the least common multiple? Okay, In order to figure out the GCF, you need to look at all the factors, the prime factorizations first, and pick the common factors and multiply them, okay? Only the common factors. In order to find least common multiple, you also figure out the prime factorization. And you figure out how many times the greatest amount of times that one prime number is multiplied by. You multiply all the prime numbers that you have for the numbers in common. Not in common, but all the prime numbers you have. Okay. So that's how you find the LCM and GCF. That was lesson 3-2, finding greatest common factor and least common multiple. And you should be able to explain how to find GCF and LCM by now. I'll see you in the next lesson.